Well, guys, so Mark Sokol just said that he is ready.
Yep,
Mark,
we're ready to go here.
Okay. So let's go to lab updates now. Let's do that. And again, my apologies for the technical bumps, but I appreciate everyone's patience. So go for it, Mark. Take it away.
Okay, I'm going to be doing this on my cell phone just for ease, because there's lots of different components in different rooms. Where we left off last was I mentioned already the fiber scope over here. We tried hooking up a regular camera to it, didn't get very good resolution, and the image was too small. So I got these USB microscopes off of Amazon and found a way to hold it in place using heat shrink, and that's giving us the best image so far. You guys can all see that in the Falcon Labs computer. It's giving you a live image from that. And here it's pointing toward the screen, toward my phone right now. So this is going to be going inside of the waveguide chamber through this hole in the corner over here. And it's going to be pointed toward the sample, which is going to be housed right about in the middle. And another thing we're going to be, so that'll give us a visual cue as to what's going on inside the sample chamber. Another thing we wanted to do is get thermal readings, because in the first initial test at 200 watts, we started melting our test holder. Things were heating up pretty fast. So thanks to Jeremiah's friend Patrick, he gave me this idea to work with Germanium lenses to basically put a thermal imaging device inside the chamber. This is a test setup just to make sure that it works. I got these from a guy in Albuquerque. It's made out of germanium. It's a little window. There's no optical change over there. There's no lensing effect on that, but I did manage to crack it when we were installing it in the many prototypes. That's what these are. These are prototype cam tests until we finally got it perfect. And there the sensor is installed. Try to keep it as thin as possible, and the readout comes out on this scanner over here. And you can see paper underneath is at 24 degrees centigrade, so that's like room temperature. So that's going to be installed on the side of the chamber, probably somewhere around over here. We're going to have to take this chamber apart now, because I have to CNC it from the inside. So that's something that we might do later tonight. Another project we're working on is called the Millisaucer project. 42 millimeters saucers, and we're using this die system over here made of 6061 aluminum, and we're pressing out little sheets of aluminum out of it. And Tom, my assistant, managed to make a whole bunch of these little miniature flying saucer disc shapes. One of them is actually full of bismuth. This one weighs about an ounce, 31 grams, whereas these weigh around 1.5 grams. Another interesting thing about thermal imaging is on highly reflective metals like aluminum or brass, we were going to need something to actually look at to get the thermal image. So we're just going over it with a Sharpie, and that's going to be our thermal imaging target. That's working pretty well. This is just a project we made on the CNC machine. That's a polar bear. Now moving forward, back in the back of the shop, we have a gyroscope system that is very near completion. Tom Butler over here is working on the code.
Yep. I was using the old servers to when I was putting the code in, and then we wanted to take and a break installed on here is basically going. We want it fast one way and then slow back the other way as the brass is spinning.
And those are the servos that are going on these devices. They have motors inside the flywheels or the gyroscopes. This is for the Gamble-inspired gyroscope inertial propulsion device. I think that's similar to what Mike was about to talk about, you know, with his technical problems with the microphone. But this is a similar device that we're very close to completion. We should have 3 complete units done as soon as the programming is complete.
So we have the flow here.
I saw you were also
the motors.
You're also contacting Pololo for technical support as well.
Yeah, they're great. They're great. Talking to a guy, Brandon, through email, and they're very helpful. Absolutely, highly recommend them.
Okay,
Sure.
and this is the micro server that we're working off of.
12 channel.
It's 12 channel,
Maestro.
but we're only going to need 6 of them. Two for the motor controls and 4 for the servos. 2 servos running in opposition on either end. So you have 1 servo here, 1 servo here. Here's a more complete unit. But we're first going to test it without hooking everything together, so we don't hear that wonderful gear churning sound. That
We don't want too much crunching going on.
yeah, we don't want to have too much crunching going on. So now we're just, I guess, just hours away from complete.
Yeah, tweaking. Just needs a little more tweaking, and should be ready to go.
Okay, what else is going on here at the lab? Inside the Faraday cage, not much has actually changed. We do have some more shielding materials coming in to help shield the infrared sensor. I'm kind of concerned about how this is going to work out with 200 watts inside the chamber. Germanium should shield it pretty nicely, but it's only a 1/16 of an inch thick. So we'll see what happens with that. But that's pretty much where we're holding over here at the lab.
Awesome. So that's your update.
Pretty much for now. Yeah. Any questions or any comments?
I think we're good.